Yellowstone National Park has been making headlines recently, with images of cracks in the ground and steam billowing into the air. Is the world as we know it ending? Should we all be running for the hills? The answer to both of those questions is no. But there is a lot going on beneath the park that's worth explaining. So let's talk about what's happening underneath Yellowstone. I am a science communicator based in the United States, and this channel explores the science that surrounds us all. Yellowstone National Park spans parts of 3 states, Wyoming, Montana, and Idaho. It is home to more than half of the world's active geysers, and more than 10,000 hydrothermal features in total. These features are concentrated in the Upper Geyser Basin, which is also known as the Wonderland of the Yellowstone. It's here where many of the park's most famous geysers are located, like Old Faithful, Castle, Geyser, Grand Prismatic Spring, and the Blue Lagoon. It's also here where scientists have been seeing some concerning activity lately. Scientists at the Yellowstone Volcano Observatory, or YVO, monitor seismic activity, ground deformation, and gas emissions from the Yellowstone supervolcano. In March and April of this year, they observed increased seismic activity along the northeast bulge of Yellowstone's magma chamber. There was also an increase in the rate of uplift in the same area. Uplift means the land is moving upwards. This is different than an eruption when the land moves downwards. The land has risen as much as 2 inches or 5 centimeters in some places, and other areas have subsided as much as 6 inches or 15 centimeters. Sounds scary, right? Well, not really. On the order of geologic time, these movements are minor. Yellowstone is a resurgent caldera. A caldera is a large crater formed by a volcanic eruption. Resurgent means that after the initial eruption, there was a period of quiet, followed by renewed volcanic activity which pushed up the center of the caldera. This created a new, smaller magma chamber within the larger one. This smaller magma chamber is called a laccolith. Think of it like a smaller cake sitting inside a bigger cake pan. Now imagine that the smaller cake is made of magma and the bigger cake pan is made of solid rock. Then picture the magma slowly pushing up against the sides of the pan. Eventually the pan will break and magma will spill over the edges. That's exactly what happened at Yellowstone around 640,000 years ago. The magma pressure built up until the land couldn't contain it anymore, and the magma broke through, creating the Yellowstone caldera. Magma continued to accumulate in the smaller magma chamber after that, and continues to do so today. That brings us back to the present day and the land rising in the northeast bulge of the Yellowstone magma chamber. One of the reasons scientists are concerned is because that area sits directly above the smaller magma chamber. So if that land continues to rise, eventually it will reach the top of the solid rock cake pan, so to speak, and magma could begin to spill over the edges of the caldera once again. In general, scientists don't think that a super eruption at Yellowstone is imminent. However, that doesn't mean that a smaller eruption can't happen. Smaller eruptions are actually fairly common in Yellowstone's history and have the potential to be very destructive, even though they would be less widespread than a super eruption. In order to understand how magma fuels Yellowstone's geysers and hot springs, we need to take a journey beneath the surface. As magma accumulates in the magma chamber below Yellowstone, heat is transferred to the surrounding rock. This heats groundwater, which turns into steam. The steam migrates up through the less dense rock towards the surface. As the steam rises, the pressure and temperature decrease, causing the water to condense and form liquid again. This forms part of a hydrothermal system that fuels many of Yellowstone's geothermal features. Some of the water makes it all the way to the surface, forming hot springs and waterfalls. Other times the water gets trapped between layers of solid rock and creates pools of boiling water. When the water reaches the surface in a confined space, it can form geysers. It should come as no surprise, then, that increased volcanic activity in the magma chamber could lead to more energetic geysers and hot springs. Scientists have seen changes in the behavior of several features in recent months. Steam emissions from the Great Fountain and Black Sand Basin have increased. Steam explosions at the Dragon's Mouth have become more frequent, and the water temperature in Black Sand Basin and Jewel Geyser Crater has increased. All of these changes are likely linked to the changes in the magma chamber. So what's the real risk here? Well, there are two things to consider: the potential for unrest to lead to an eruption and the potential for an eruption to cause widespread damage. Let's start with the likelihood of unrest leading to an eruption. Eruptions are driven by pressure. If pressure increases enough to overcome the strength of the rocks above it, then magma will find a way to escape. Scientists closely monitor the amount of pressure building up in the magma chamber by measuring the frequency of earthquakes. They do this because magma movement often causes earthquakes. The frequency and strength of the earthquakes have not changed significantly in the past few months. Therefore, scientists don't believe that there is an imminent eruption at this time. Another way that scientists measure pressure is by looking at gas emissions. Increased gas emissions could indicate that pressure in the magma chamber is increasing. However, gas emissions from Yellowstone have remained relatively stable in the last year. Based on this evidence, scientists conclude that even though there may be some localized unrest in the magma chamber, it does not pose an imminent threat of eruption. Now, let's discuss the potential for an eruption to cause widespread damage. If Yellowstone were to erupt today, it would cause significant damage to life as we know it. An eruption of the magnitude of the 1883 eruption would release somewhere between 240 and 500 billion cubic feet, or 6.8 to 14.1 billion cubic meters of material. That much material would cover much of the western United States in ash. And even small amounts of ash can cause significant problems like collapsing roofs, disrupting transportation and damaging buildings and crops. It would have huge implications for air quality across the country. For perspective, the 1980 eruption of Mount St. Helens in Washington released approximately 2.3 billion cubic feet, or 65 million cubic meters of ash. That was enough to cover much of the Pacific Northwest in a thin layer of ash. To put the potential impact of a Yellowstone eruption into even clearer terms, the 1883 eruption would produce 100 times the amount of ash. It might be helpful at this point to distinguish between two different types of eruptions, explosive and effusive. Explosive eruptions are characterized by violent explosions that project ash and gases high into the atmosphere. Effusive eruptions involve the relatively gentle outpouring of lava. Most basaltic eruptions are effusive. Basaltic magma has a low viscosity and is rich in magnesium and iron. This makes it runny and less likely to trap gases. The gases that are present can easily escape, which decreases the pressure and mitigates the explosivity. On the other hand, rhyolitic magma is very viscous and poor in magnesium and iron. This causes gases to become trapped in the magma, which increases the pressure and promotes explosive activity. If the magma at Yellowstone were to erupt in an explosive fashion, the ash would travel across the United States and possibly even farther. However, if the magma were to erupt effusively, the lava would travel much shorter distances. The good news is that the magma at Yellowstone is mostly basaltic in composition, which means that it is more likely to erupt effusively, but the shape of the caldera plays a big role too. Because Yellowstone is a resurgent caldera, there are weak points on either side of the magma chamber. If the magma were to erupt from these weak points, the lava would travel relatively short distances before encountering a natural barrier. Here are some examples. If the magma were to erupt from the southern portion of the caldera, it would travel north into the Absaroka Range. The northern portion of the caldera has a weak spot near the town of Gardner, Montana. If the magma were to erupt from this area, it would travel south towards the towns of Chico and Prey. These are obviously just two scenarios, and there are many others. But the point is that an eruption from any of these spots would result in lava traveling relatively short distances before encountering a natural barrier. As you can probably tell, there are a lot of ifs here. And scientists agree that a large eruption at Yellowstone is unlikely to happen anytime soon. In fact, the YVO hasn't issued a Level 2 alert in the 25 years that the alert system has existed. Level 3 is the highest level of volcanic alert and has only been issued twice in Yellowstone's history, both times for short periods following large earthquakes. So, while it is fun to speculate about what would happen if Yellowstone erupted, it's important to remember that the world as we know it would not end. At worst, there would be widespread ash and the need to relocate the thousands of people who live in the area. It would certainly be a massive undertaking, but it's not the end of the world. And who knows? Maybe someday we'll learn that the Earth has a sense of humor and just wants to give us a hard time. Just a little Earth humor for your consideration. Thanks for watching this science show, and go explore the world for yourself.